Here we are going to use the laws of logarithms to evaluate several expressions. The first one is log base 3 of 81 minus log base 3 of 3. And we are to, first of all, combine the expressions into a single logarithm. We have the difference of logarithms with the same base. That's going to be a logarithm with that base of the quotient of those two values. So log base 3 of 81 divided by 3, which is log base 3 of 27, which is log base 3 of 3 cubed, and so the answer is 3. The second example, log base 2 of 10 minus log base 2 of 35 plus log base 2 of 112. So in this case, we work from left to right, and where we have the difference of log base 2's, we're going to write log base 2 of the quotient of those arguments. Then we will have plus log base 2 of 112. Now we're going to write the sum of the logs base 2 as the log base 2 of the products, or the product of those arguments. I see that 7 goes into 35 and also into 112, and then 5 can cancel into the 10. So we get log base 2 of 32. 32 is 2 to the 5th, and the log base 2 of 2 to the 5th is the exponent, or 5. In the next example, again, we work from left to right. Again, we'll have the difference of the logs is the log with the same base of the quotient. This time minus the log base 5 of 20, which will be the log of the quotient again. So 16 divided by 20, all divided by 20, which I'm going to write as 20 over 1, which will give log base 5 of 16 over 20 times 1 over 20. Four goes into the 16 4 times, into the 25, and then again 4 goes into 4 once and into 25. So we're getting log base 5 of 1 over 25, which is log base 5 of the reciprocal of 5 squared, which is 5 to the negative 2. And so the result is negative 2. And the last expression in the set, the log of 10 to the 100,000th power. So this time I can replace the log of 10 to the 100,000 with 100,000 because it is the exponent on a 10. That leaves me with log of 100,000, which is 10 to the 5th, and that will leave me with 5. Since we're looking at the common log, log base 10 by default.